Hello everyone! Today I'm going to show you how to prove the sine and cosine addition formulas. If you want, you can memorize these formulas, or any formulas, but knowing how to prove them will give you a much deeper understanding. That's actually the difference between memorizing and knowing. If you truly know something, you won't forget it. But if you just memorize it, you probably will. Let's get started. As you can see on the screen, we have two right triangles and two angles labeled A and B. Our goal is to find the sine and cosine of the sum of these two angles, expressed in terms of angles A and B. Let's say the length of side BD is 1 unit, just to keep things simple. So what would the length of AD be? Remember, sine means the opposite side over the hypotenuse. Since we took the hypotenuse as 1 unit, AD becomes sine B, right? In the same way, side AB becomes cosine B, because cosine means adjacent side over hypotenuse. And since triangle ABD is a right triangle, we've actually just proven another very important identity. Sine squared plus cosine squared equals 1. You'll come across this equation everywhere. All right, let's continue. Now look at triangle ABC. We're going to apply the same idea as before. What did we do earlier? We took the hypotenuse and multiplied it by the cosine of the angle to find the adjacent side. So here, BC becomes cosine A times cosine B, right? To find the opposite side, we multiply the hypotenuse by the sine of the angle. That gives us AC equals sine A times cosine B. Great. Now let's draw a perpendicular line from point D. Let's call the point where intersects side BC as E. Then, from point A, draw another perpendicular down to line DE and call that point of intersection F. Since AF is parallel to BE, this angle here must also be A, right? That means the other angle in the corner is 90 minus A. So angle D ends up being angle A again. Now let's look at triangle DAF and find the lengths of the sides using sine and cosine. If we take DA, which we said is sine B, and multiply it by cosine A, we get DF. And what about FE? That's the same length as AC. So now we've found the total length of DE. What is sine of A plus B? It's the opposite side over the hypotenuse. Since our hypotenuse is still 1, the total length of DE equals sine of A plus B. And what did we say DE was made of? It's FE, which is sine A times cosine B, plus DF, which is sine B times cosine A. So the sine of A plus B equals sine A times cosine B plus sine B times cosine A. And that's our sine addition formula. Now let's look at the cosine addition formula. To do that, we need to find the length of BE. We already know the full length of BC, which we found earlier as cosine A times cosine B. Now we need to subtract EC from BC, and EC is the same as AF. So how do we find AF? We just multiply the hypotenuse by the sine of the angle. That gives us sine A times sine B, right? So BE, which gives us cosine of A plus B, equals cosine A times cosine B minus sine A times sine B. All right, I hope this way of looking at it helps it stick in your mind better. We'll be proving more theorems like this in future lessons, but for now, that's enough. See you next time.